All right, so finishing up with what we had looked at last time, we were talking about sorting algorithms and things of that nature. And so what I'm going to do here is, first, let me run this and see if this completes in a reasonable amount of time. We're going to do some time comparisons of some of these different algorithms, which we had already kind of done, but then one was taking so long because I had given it too many items to sort, which might actually be the case now. It's kind of difficult to time this sometimes because if I'm running it while I'm not presenting, then of course it's going to take a little bit less time because my computer is not juggling as many tasks simultaneously. Yes, 26 seconds for bubble sort. That's pretty long. So let's try this with 2 and see if that is going to work out a little bit better, maybe even 1. And so trying to set up sort of a consistent environment is not always the easiest thing to do, because as soon as I start recording, that's going to take a little bit of additional time and so on and so forth. But that's pretty good right there. So what we're going to look at here is we've got the same timing mechanism that we had looked at before, but I also, here I'm introducing another kind of sort. So this is the standard sort in the standard library, and this is in the algorithm class. So the way that we sort things with standard sort is it requires an iterator. It requires 2 iterators, a begin iterator and an end iterator. And so if we're using something like a vector, this works out just fine. We give it the first item in the list, we give it the last item in the list, or past the last item in the list with the end function. And so that will allow us to do a comparison using the standard sort. And so what I'm also going to do is, after these lists have been sorted, I'm going to sort them again. So I'm going to use the same containers that we used for everything, and I changed things up a little bit. I put bubble and insertion first, and then selection sort third, and standard sort is fourth. So what I'm going to do is the same sort on these containers. So we might think that if we sort data that's already been sorted, it should be pretty quick, right? I mean, how difficult is it to do something that's already done? Probably not all that difficult, right? Seems like a pretty easy to do task. Like, hey, can you do this task for me? Sure. By the way, it's done already. Oh, okay. I guess I can do your already done task. Done. That was easy, right? So that's easy enough for a human being to say. However, the way algorithms verify are they finished might not be the same as what you think. It might not be that easy. Right? Because again, this goes back to how much does a human being know or can very quickly grasp or interpret versus how much does an algorithm know and how quickly can it grasp or interpret something. Depending on how much data we have, it might take a while. So let's take a look. So we run this. We'll have the bubble sort algorithm take about, assuming it's consistent from the last run, 8-9 seconds or so, and then the other ones a little bit less relatively. So we'll do the first pass where we run bubble sort, and then we run an even a little bit less time, or more time rather. So 12 seconds for a bubble sort, about 4 seconds for an insertion, about 3 seconds for a selection. Standard sort, ludicrously fast. Standard sort completed in a tiny fraction of the time, right? For thousandths of a second, right? So standard sort is the clear winner, no questions at all. However, look at this right here. So we're sorting some data that has already been sorted. So a bubble sort completes very quickly, 0.02 of a second to finish, and insertion about as fast, slightly faster even. Selection sort, on the other hand, notice how selection sort seemed to take pretty much the same amount of time, even slightly slower. Now, if we're talking about a 10th or a 100th of a second here or there, it's really not that big of a deal. We can have those slight inconsistencies. But it's a little bit interesting to note that selection sort is really no better if the data is already sorted or not. All of the other sorts, on the other hand, as expected, perform extremely well and don't do much work at all, right? So bubble sort, massive reduction in time, almost 13 seconds down to 2 thousandths of a second. Insertion from 4 seconds to 2 thousandths of a second. Selection, basically no change. And then standard sort, still ludicrously fast, all right? So not all sorting algorithms are created equal. We had talked about this a little bit last time. And so, we can't always have one algorithm that is always perfect, that is always good. I mean, even doing a comparison here, selection sort was better than insertion sort in one scenario, but it was inferior to insertion sort in another situation. Same thing, selection compared to bubble sort, much better than bubble sort, way better than bubble sort in one case, but awful by comparison, like just completely terrible by comparison in another situation, right? So not all algorithms are created equal. Not all algorithms will sort already sorted data equally, right? And the reason for that just comes down to the way that the algorithm works. Because with selection sort, what it does is, it picks an item from the list or an index, let's say index 0, and then it goes through all the rest of the data to find the best candidate for index 0. Well, if the best candidate is already at index 0, the algorithm has no way of knowing that. The algorithm has to go and check every single other element to verify, to prove, yes, this element at index 0 is in fact the best choice. Now that we verified that, let's move to index 1. How do I know index 1 is the best element to go here? Well, I need to verify this by checking every single other element and so on and so forth, right? So it all depends on how the data is structured in many cases, but selection sort, by and large, is just a bad algorithm. I would say selection is in some cases, even worse than bubble sort. Bubble sort's not a great algorithm either, but if your data is already sorted, then, well, bubble sort will be the champion. So something like standard sort, on the other hand, is pretty reliable. It is a significantly efficient, optimized algorithm, and generally, using standard sort for everything or as often as you possibly can is a pretty good suggestion. There may be other algorithms that perform better than standard sort in some scenarios, but usually we choose algorithms that are most of the time effective. These three algorithms here are usually not very effective. This is a specific case that I'm setting up just as an example, but by and large, those are three not great algorithms. If you're dealing with very, very small amounts of data, they're okay, but for any kind of serious work, they're not great. And something else is preferable, like standard sort. I can't even really think of a reason where you wouldn't want to use standard sort. Maybe an extremely large amount of data, but I don't even know that it has any sort of upper bounds where it can't operate on a certain quantity of data. So standard sort is the clear winner in all of these tests. All right. Any questions about that stuff right there? Questions about the comparison of these different algorithms, or how efficient they might be in some scenarios versus another, or any of this stuff right here? If there are no questions, then we'll just move on to the other stuff that we'll get to today.
Professor Fox?
Yes.
Isn't there kind of an advantage to using these when you have low memory resources? Because the n-squared computational efficiency ones don't use any external memory, but like quick sort or merge sort all require the allocation of external arrays.
There could be. Yeah. If you're in situations where memory is extremely limited and every last function, every last algorithm must be as memory efficient as possible, yeah, there may be reasons where you have to use slightly more or slightly less, in some cases significantly less efficient algorithms due to memory constraints. It's not often that we're in, well, in my own experience, I should say, it's not often that I have ever been in that kind of situation, mostly because of the work that I do or have done was never in those very memory limited scenarios. But if you're working with very low level hardware, integrated chips or something like that for very tiny devices that might run, in some small, very small, low powered computer, then yeah, you might have to make those kinds of trade-offs. And the trade-off of memory versus sort of processing speed, or just memory versus speed, that's a trade-off that's been around forever. And I don't know that that trade-off will ever go away. Do we store stuff in memory for faster access if we can, or do we choose not to use as much memory and instead we have to kind of recalculate things over and over again? That trade-off's been around forever. And like I said, probably will still be. But yeah, that's a good question. Good question. Any other questions? All right. So with that, we'll sort of leave sorting behind. I don't think we'll be revisiting this anymore this semester here. So let's take a look at this program here, which this is the same thing that we had before, although I think maybe I made a change. I deleted a line and tried to recreate it. I think I got the color wrong or something like that. But this is what we ended up with the last time we were looking at the sfml library, right? So we have something like this, kind of a basic setup here, but what I'm going to do is show how, if we wanted to implement something that was maybe a little bit more sophisticated, or if we wanted to start to do something a bit more complex, like instead of having just one object or one circle or something like that on the screen, if we wanted to start writing our own classes or whatever else, then we'll look at how we can go about that. So in an application like this, or when we're working with these external libraries, what we're really getting is kind of this sandbox sort of thing where we have, maybe not sandbox, maybe that's not the most appropriate metaphor, more like a garage, like a workshop, where we have all these tools at our disposal. And the tools in question are all of the sfml things. So we've got, rectangles and vectors and textures and sprites and all this other sort of stuff, right? And so what we're going to do here is look at how we can start to leverage that with things that we already know how to do, right? So let's say instead of drawing, the boxes or whatever as kind of background objects, what if we wanted to draw something like this little asteroid right here? So if I just pop this thing open here, zoom in a little bit. So just this little tiny shape to make an asteroid as kind of a background object somewhere as a bit of scenery or something like that. So what we would have to do is we would need to do the same kind of process that we've done before. So we'd say sf texture. We'll make one of these asteroid. That's not the letter F. There we go. We'll say asteroid texture dot load from file images asteroid.png, right? And so then we make a sprite based on that. So we say sf sprite asteroid, and we'll set a texture for that. So texture, right? Of course. And so then if we wanted to draw that, the same thing as drawing any of these other things down here, we could say window.draw. And if I wanted to set the position of this somewhere, we might say asteroid.set position. Let's just say kind of randomly 400, 400. So a little bit down in towards the center of the screen. So we do this quick little test just to make sure, is this thing actually working, right? Do I have this image up in drawing? And there it is, right? There's our adorable little asteroid. And so if we wanted to draw more of these, then we could certainly do that. At the moment, we just have the one object, right? Or the one sprite. Now, as we saw with drawing these boxes, we can use one sprite and draw it multiple times if that's the goal, right? And that's all fine and good. So this is drawing one asteroid, draw multiple asteroids, and we could do something like this. Actually, I'm just going to steal that loop. So we wanted to draw, 10 of these things, then we could do something like that. And hold on, sorry. There we go. Meant to just copy that word, ended up copying the whole line. So we could do something like this, which is still just going to sort of draw them in that kind of stair step pattern, right? And so, you know, that's not quite giving us our maybe intended goal of what if I wanted to, you know, populate this window with a whole bunch of asteroids. If I wanted to make an asteroid field in the background. So what I might do is, I mean, we stop and think about this, like, okay, right now we're in this, you know, sort of pattern here where, hold on, let's close this, close you. So I'm drawing things right here and then right here and then right here and so on. But what if I want to draw one here and here and here and kind of all over the place, right? I really want some sort of randomization. I want some random numbers that I want to generate. And maybe before I draw the thing, I want to set the random values, right? So instead of doing this loop here, in setting the position to this, what if I did something like int random x equals rand mod, and rand is not a great random number generator. I have a video. Did I not post a video for that? I have a video of how to write a random number generator, and I think it's posted on the how-to page. If not, then I will. But it's a just better version of the random, the built-in rand. And so, and I see there in the chat that, no, I did not. Well, okay then. So I will post that after class, but this will suffice for right now. So we could do rand mod, let's say the width of the screen. So window.width. And no, I'm sorry, I'm getting that mixed up with my other class, which has a width variable in some stuff that we use in there. What I need to do is call window.get size and size.x. This will give us the x dimension or the width dimension of there. So random number between 0 and width of window. Should have just copied and pasted this whole line and changed the one component, but random number between 0 and height. Okay, so then I can set the position to random x, random y, and then let's go ahead and draw this, which might give us some weird results. I know it's going to give us weird results, but let's watch. So here we have our very rapidly moving asteroid fields. If we try to navigate through this, we're just toast. I don't care how great of a pilot we are. I don't care what sort of computer algorithms we're using to navigate this space. We're just done. These asteroids are moving way too fast, and you know, there we go. So no, Nicholas, Han could not. I love Star Wars. Han could not. No, that is the end of Han Solo. I'm going to navigate that. Nope, no, you're not. C-3PO kicks in. The odds are 0, actually. Never tell me the odds. No, I'm going to tell you, Han. The odds are 0. We are going to die. Goodbye, everyone. And that's the end. So I love Star Wars. I love Star Wars. Han would die. I'm sorry. And I'll take that one to Han's grave. Okay. So what's happening here is the reason this is all, you know, sort of crazy and chaotic and whatever else is because we're doing this repeatedly. So what I want to do is generate a random position for an asteroid and set it to a spot and then leave it there. I don't want to make that asteroid get a random position over and over and over again. That's not really going to work out so well. So that's kind of like if I did this for, let's say, this space station right here and change the location of it, and then it's just going to teleport over and over and over again. That's not what I want. But what I do want to do is set this position once and then get into this loop, because this loop right here, while window.isOpen, this is going to run over and over again. All of this code right up here, this is essentially our initialization. And so really end of initialization. There we go. That's how you spell. Something like this, right? So any code that we want to kind of set up something for our program, we really should do that up here. Or if we're writing a class, we can do that in the constructor of that class, or whatever else. And so if we wanted to set these kind of random positions for these asteroids, what I might want to do is not just have one asteroid, right? So this is create a single asteroid. And that should be right there, right? Create multiple. So what I'm going to do here is make a vector of SF sprite objects, and we'll call this asteroids. Lots of asteroids. And so I'm going to need to include a vector up here. And so now we have a whole bunch of sprites here. And what I'm going to do is for each one of these, I'm going to set a position, but I'm going to do it once. So once when my program first starts, and then call it done. And so I can take this code right here, which will work. And 0 I is less than 10. Okay, so let's say we want 10 asteroids. I'm going to generate a random number, and then I'm going to say, let's make SF sprite temp asteroid dot set position to random X, random Y, and then let's take my vector of asteroids and do a push back this temp asteroid. Okay, so now I'm going to build this little collection of these things. And so when it comes time to actually using these and drawing them somewhere, I'll come down here and drawing multiple asteroids. This is really going to be a loop through our vector. So for I is less than all the asteroids that we have, window dot draw, and I just need to get asteroids sub I. And really, I can just take that out. So now we've set the position once, and then we can go ahead and draw all 10 of them. And so, interesting. So that doesn't seem to have worked the way that I thought. I know what the problem is. Hold on. I got a fix for this. So the issue is, Nicholas called it, they're shy. So we have some shy asteroids, and what we need to do is sort of coax them out by tempting them with a texture. So I made this sprite, but I never gave it a texture. No texture, sad asteroid. So what we can do is just in the constructor, just like we have in previous examples here, give it a texture like so. So that'll solve the problem. Basically, we were drawing sprites that had no texture, and they just appear as nothing at all. So now let's try this, and I do believe this will work just a little bit better. And there, look at that. Now we've got a bunch of asteroids. All right, so they're kind of scattered about. There's just the 10 of them. Technically, there's an 11th, this sort of Lone Ranger asteroid right here. But otherwise, there we go. Now, if I wanted to kind of randomize things, I could do that. But I would need some way of kind of interacting with the application, right? Maybe a button to randomize things, or just click my mouse or hit the space bar or something like that. But every time we run this, we should get a different. Actually, we're going to get the same pattern because the random number generator is not being seeded currently. So what I would have to do at the very least is just call srand and pass that as 0. So what this is going to do is this is going to seed the random number generator with our system time. So every time I run my program, the number generator gets a different seed value, and then we'll get a different sequence of random numbers. Right. So now we have something a little bit different there. If we run this again, we'll have another different pattern, and so on and so forth. Right. So, you know, we do have some that are kind of lumped right on top of each other. That's fine. We could just say they're at different depths, basically. Otherwise, you know, we would have to do something to sort of determine are they overlapping with any other asteroid, which actually wouldn't be too difficult. Like right here, before I do this push back, you know, check to see if the asteroid overlaps with any other, you know, that would be a loop through all of the other asteroids. I'm not going to worry about that right now because that's just really not that much of a concern. But if we were to change this, if I go from 10 to, you know, let's say 25 of these things, then we'll have a whole bunch of other asteroids. And I changed the color on the texture of this to sort of appear a little bit brighter, have a better contrast, sort of. They used to be a little bit darker. I've done this example a little bit before in, I think last semester maybe. They sort of looked like meatballs, and that became the unofficial name. Everything was just space meatballs, and all the demos revolved around that, which was fun. So here we have, you know, a whole bunch of asteroids floating around in space, right? And so if we wanted to, you know, do something else with these, let's say we wanted to make the asteroids move or rotate or change size or whatever else, you know, let's look at some of the things that any given object or sprite could do. So before we push this onto that container, we have another. Or let's take a look at the different functions that we have available to us at temp asteroid dot. So we've got things like color. We talked about that before, rotation and scale. So we could potentially use, you know, the scale functionality, and we could use that to change the size of something, right? So let's say if we just wanted to set the scale, so what we need to do here is provide a float for the X and a float for the Y, right? So let's say, well, let's see, the random number, that's just going to generate integers. So let's say we generate a number between, say, 1 and 10. And so what I'm going to do is change the scale of this, because a scale of 1 is 100%. So if I set the scale to 2, well, that's going to be twice as big. Suddenly that's humongous. If I set it to 0, then it's going to vanish. So I really want to adjust it by small amounts, right? So what I could do is, let's say maybe float range equals, let's do a random number between 1 and 10. So this will give me a number between 1 and 10. Let's divide it by 10. So then that'll give me like sort of a percentage, and we'll do 1.0 f plus range. 1.0 f plus range. So some of these will end up getting a little bit bigger. Some might get very large. 2 would be the maximum. We could always tweak this a little bit. This might suffice for right now, just as a quick test. Because I mean, this is just all sort of example stuff here of things we can do, not the way we might implement any one particular feature as most amazingly as possible. And so now we've got asteroids of different sizes, right? And so they're being scaled uniformly right now, right? And so, you know, the whole thing is going to get bigger in exactly the same way. So if I wanted to change that, what I might do is this same process. Let's call this range X and range Y, and we'll do X and Y. And so if we run this now, then since we're generating two different ranges, we might have these stretch a little bit or squash a little. So we sort of have, taller, shorter, and things like that. Although all of these are getting larger, right? I don't have any kind of specific, I'm not shrinking them at all. They're only getting larger, right? And what we can also do is for each one of these, we could do something like apply a random rotation. So let's say int rotation equals rand mod. Let's see, when they spin up to 360 degrees. Yeah, they use integers for the rotation, so that'll be fine. And then temp asteroid dot set rotation to that. So now we'll have a bunch of asteroids that are different sizes, and then they're also rotated a little bit as well, right? So just a couple of little parameters here and there, and we've got a bunch of variety. Right? And we could certainly increase the number of these or whatever else. Might want to, turn off the squares or the boxes and the circles here. Maybe keep one of them. That's just the star off in the background or whatever else. But yeah. So if we wanted to make things a little bit more complex, like we're doing a lot of stuff right here just in this loop iteration, and so if we wanted to take this and maybe make an object or something like that out of this, let's say uh-oh, losing the screen here. Uh-oh, recording has and unmuted. There we go. All right, we're back. So I'm not quite sure what happened. Just Zoom suddenly said, hold on, I need a break, please and thank you. Okay, sounds good. And by okay, sounds good, I mean, I can't say no, so take all the time you need. So as I was saying, if we wanted to take all of this code here and maybe, let me share the screen again. There we go. All right, perfect. So if we wanted to take this code here and turn it into a class or something like that, and maybe now I could have a vector of asteroid objects instead of just sprites, because maybe I want to do something a little bit more complex. Maybe these asteroids could collide with other asteroids, or they had something like hit points or durability if I wanted to somehow destroy them. Maybe we make a game where we have to protect the space station from asteroids and fire lasers at it or whatever else and blow these things up. If we wanted to do all that, defining some kind of asteroid object might be a helpful thing, right? And we could take a lot of this code in here, a lot of this initialization stuff, and do exactly that. So maybe we'll save that video for another time because I wanted to get to something else, and we are running a little bit short on time. We'll see if we have a bit more time at the end. If not, then maybe I'll push that to another time. I could certainly record some of these things offline here. So what if we wanted to, change something about this? Like, let's say, for example, at some point I want to get rid of all of these asteroids. How could I do that? Or if I wanted to add a new one, right? So I start with, let's say, 25, but what if I wanted to hit a button and add a 26th or a 27th or whatever else? Maybe repeat all of this code and do all of this again. How could I do that, right? So the first thing that we would want to do if I needed to have some sort of interactions with this program, I'd want to make sure that I can get the location of something like my mouse cursor, and also detect something like mouse presses. So let's say we, well, first, yeah, let me turn off those boxes, right? Because that's a little strange to have them here now. We'll just get rid of these guys here. Uh-oh. Oh, and there's a pause again. That seems to be Visual Studio this time and not, okay. So I'm not really sure what's happening right now. Apparently my computer is not a big fan of the streaming process. So let's try doing this. There we go, maybe that was it. Let me actually turn my performance up since I'm plugged in and don't really need to worry about battery at the moment. Yeah, I was going to turn off the boxes, right? So we can get rid of those things right there, okay? So if I wanted to get my mouse for any kind of interaction, what we want to do is use this loop right here, or this this polling loop, this event loop. And so if you're trying to respond to any kind of events that can happen, and there's a whole list of them on the sfml developers website. They have a whole section about events, but the one we're going to look at here is if event.type is equal to sf event mouse button pressed. So this event right here is just if a button was pressed. That's it. A mouse button was pressed. Then what we need to do in here is check to see which button was pressed. So if event.mouse, or mouse button rather, dot button is equal to sf mouse left. So if we get into here, let's say as a simple test, let's just print out the location of the mouse cursor. Semicolon, so it compiles, I guess. Your comments don't need to compile, by the way, it's fine. So if we wanted to do that, first we have to get the mouse cursor, right? So there's a function in sf mouse get position. And so we're not really calling this as part of any kind of object. This is what's called a static function. And we haven't really talked about the static keyword up until now. It's not something we need to use all the time in C++, but it could crop up. We'll look at that a little bit more later on. But the get position function returns a sf vector 2i. So vector 2 has an x and a y position, but vector 2i is an integer based vector. So the x and y are integers as opposed to floats or unsigned integers or whatever. So we do sf vector 2i. And we could say mouse position, not mouse potion. There we go. Now, if we were to use a different data type here, like the vector2f, we'll get a compiler error because we can't convert from this one type to this other type. Like the underlying data types we can convert, but formally, though, they are two separate classes. It's like trying to convert dinosaur to orange. Even though they might have some similar data behind the scenes, they are different objects. Now, something else we could do in this sort of situation is we could just use the auto keyword and then boom, done, take that data type. And so the auto keyword is very useful in these kinds of situations because we might know that, yeah, it's got an X and a Y, but is it a float X and a Y or an int X and Y? Well, what I'm going to do with it, it doesn't matter. So let me just make an auto variable and then boom, I don't need to think about that. So I can focus on other parts of my program. And so we can do something like this, mouse position plus, not plus, that's another language, and mouse position dot x dot money punked. That's a strange mouse position. There we go. I'm not sure what that money punked was. Some variable somewhere called money punctuation, possibly. Anyway, dot y. That's what I meant to type. Occasionally, if you're using hotkeys and doing autocomplete, if you make a typo in what you started typing and then it autocompletes whatever your typo was, you can find all kinds of fun keywords and weird things that you never intended. So in any case, let's just try this. So if I click my mouse, then we'll see the mouse position up here. Every time I click my mouse, we get something printing out over there. Now, one thing that's kind of interesting to note here is that the top corner of the window, this generally, for most graphics-based systems, this should be 0, 0. However, notice how this top corner is a pretty large number, and if I move my window, this is a different number. This top corner should be 0, 0 or close to it if I can get right on the pixel, no matter what, no matter where my window is. So what's happening here is sfml, by default, when we call mouse position, this is getting the absolute position. Where's the mouse in the overall window? And what I would rather do instead is call this function and use the window variable that we created at the very beginning of all of this, or at least that was created as part of the sample code. So we have this window variable that is the sfml window. And so when I call get mouse position, I'm going to pass that window into that. And so this is going to be relative, let's say relative to the actual window. 0, 0 is the top left. All right, so we run this now, then we'll get the proper mouse coordinates. Right, so all the way up in the corner here, this is very, very close to 0, 0. If I can get right on that exact pixel, but you get the idea, right? You know, with a relatively high resolution display, it can be hard to get exactly that pixel, but close enough, right? And so the center of the window, no matter where my window happens to be, ooh, that's a very strange stretched out window. Let's not do that. But this will still be 0, 0 or very close to it, depending on how close I can get. All right, so that's step one, just get the cursor position, okay? And something, you know, as relatively trivial as that still requires a little bit of explanation and understanding of what's really happening here. And the same is true for everything that you will ever do. Just about any code you ever write, if you're using some new language or some new library, you know, it might seem trivial, just get the mouse cursor, but there's still a little bit that you've got to learn. And so you have to understand, you know, how do functions work and how do we access this as part of a namespace or a class or whatever else. All those things that we talked about ages ago that seemed like they were terrible and boring things that you didn't actually need to know. Surprise, you do. So now that we have the mouse position, what can we do with that, right? So let's say we wanted to just do something as simple as clear all of these asteroids. So to do that, what I'm going to do is make a button to do this. And so I've got another image here that I'm going to use, this clear button. And so we'll say sf texture clear button texture and clear button texture dot load from file images slash btn clear and sf sprite clear button texture, right? And so now that I have that and we want to draw that somewhere, it's going to appear at 0, 0 all the way in the top corner. That's fine for right now. Clear button. Okay. Now, if I want to click on that thing, what I really need to do is check to see if we've clicked on the button. Now, sfml makes this very easy to do. Now, essentially, what we want to do in this case is if I have a button here, it's going to have some X and Y position, and then it's going to have some width. It's really going to stop right there. And then it's going to have some height right here. So if I click somewhere, I want to check and see is the X, Y position of this point inside this space here. So if my X happens to be greater than this X and also less than this X plus the width, then that means I'm somewhere in this space right here. And if the Y position is in this space right here, then we're good. That means we clicked on a particular sprite, or we clicked within a certain box, essentially. So that's not really all that difficult to write ourselves. It's really pretty trivial in the grand scheme of things. However, sfml makes this even easier. So what I'm going to do is, there's a function that we can call. So my clear button has a function called get global bounds. This returns a data type called sf float rect, float rectangle. And so we could again use the auto keyword for this, or we could do sf float rect, whichever. And so this particular function right here, we can say rectangle dot contains. And so this contains function accepts a point in sf vector to f, and it returns a Boolean, true or false, does this rectangle contain a point, which is basically that algorithm that I mentioned just a second ago. So this will basically do this kind of thing for us. So we can give it the mouse position. Now here, we're going to run into a minor issue, because what this function takes, and we'll often encounter this when we're working with any kind of graphics library that's trying to do different kinds of things, we will end up with mixed data types. So this function, mouse position here, is of type vector to I. However, the contains function requires a vector to f. So that's a little bit of a problem, right? So dot contains requires vector to f, but we only have a vector to I. So we can convert easily enough. There's no native conversion for this. So what we can do here is say sf vector to I mouse pause int version, and use mouse position dot x, mouse position dot y. So now we're converting the floats, or excuse me, there we go. We're converting, and that should be float as well. We're converting integers to floats right here, and then we'll just use this. So if this is true, and this is a function that returns a Boolean, so I don't just want to call the function, but if this is true, then do some stuff, right? If we clicked on the sprite, then do stuff, right? So we could just say, yes, clicked the thing, else no, didn't click the thing, right? So that'll be fine for right now. I'm also still printing out the mouse position, but that's okay. So now we have this button up here, and if I click somewhere, we see no, didn't click, no, didn't click. But then if I click on it, yes, we clicked on the thing. Cool. So now we can do this check of, am I clicking on a particular sprite? That's the first step in sort of encoding some kind of interaction, right? Detect that your input is matching up with what somebody thinks, right? Because if I'm going to, touch some object, like if I have my phone right here and I go to touch it, I might expect that I get some kind of feedback, right? I aim at the thing, I touch it, and then my finger feels the pressure of the object or the surface or whatever else. We don't have that kind of feedback in this digital sense, but I still want to make sure that the code is written in such a way that I can reliably do something when I'm expecting to do something, right? So I don't really need this bad result or this false result, but what do I actually want to do in here? So let's say we just call asteroids.clear. That's going to get rid of all of my asteroids from this vector that we created earlier right here. If this vector is empty, then that means the drawing code down here, which loops through however many asteroids I have, well, that's going to loop 0 times, and so it's going to draw nothing. So we run this really quick. got a whole bunch of asteroids here, hit the clear button, and then all of them are gone except this one tiny little asteroid because he was not part of that vector. He was his own asteroid, and he marched to the beat of his own cosmic drum or whatever. And so he was always being drawn right here. He is unaffected by the vector. Okay. Now, if I wanted to do something similar to that with another button to maybe make a new asteroid, we could repeat all that. And this will be the last thing that we look at because we are just about out of time here. So let's say we make a new one, and we'll do new and new and new. Okay. And so then if I want to draw this, I need to change its position a little bit. SF new button dot set position. Hold on, this is still running. Close that. So I'm going to set the position of this to be 0, 200 maybe. That's probably more than enough to move it down. And then in here, if I clicked on that, so I've already got my mouse position converted to floats, but then I'm going to do, let's see, this rectangle. I'm going to do auto new. I can't use the new keyword. New rectangle equals new button dot get global bounds. And if new rectangle contains my mouse position, then I'm going to add a new one, asteroids dot push back some new asteroid. I'm going to steal this code right here. Now, since I have this same code in 2 different locations, it might be a good idea to turn this into a function somewhere, but I'm going to make a new temporary asteroid and then push that back right here. So let's run this and see if this works. And if it does, we should be able to hit that button and get a new asteroid. I don't think I actually drew my button anywhere. So, and even all of this code here, this is starting to get a little bigger and clunkier, you know, drawing all the buttons. That might be a function somewhere called draw user interface, drawing all of these asteroids and space stuff. That might be another function to draw that, just to kind of break things into smaller pieces, but that's another topic for another time. Okay, so there's the new button. I can clear everything. And now I can keep clicking this button and I get a whole bunch of new asteroids. Clear, let's get a bunch of new ones. Clear, let's get a bunch of new ones, and so on and so forth, right? And all I'm doing is kind of sending data over to that vector, modifying it, adding to it, removing it, and you know, then my draw code is just using whatever the container has, right? And that's something that you know, a lot of code will end up working like that, where you have something, some kind of a loop, some sort of data structure, and you're saying, hey, do something for every element that you have in the container. The number of elements might be 0, it might be 10, it might be 1,000, but still do something for however many elements you have. And then all we're doing is kind of playing around with the count. And this little bit of code here is none the wiser, right? So I'll leave it right there because we are unfortunately out of time, but I'll certainly hang out and answer anybody's questions if anyone has any. So that said, any questions, comments, concerns? Kieran, do you have a question?
Yeah, sorry. Kind of a silly question, but I watched the video for like the sfml setup that you posted. Like, so can we just like rename that file and just use that for the project, or should we make a new one and go through all the different setup things?
Which
project or file? Sorry. Like the whole project that we made, and so I kind of just followed along with your
oh, as like part of the initial setup?
Yeah.
Oh yeah, absolutely. Because all that is connecting all of the pieces to make the SFML library work with your project, or sort of prepare it to work with your code. Once you have all that set up, then it's up to you to write the rest of the code beyond that.
Okay. Is this file like anywhere on Canvas, like to look at for a reference, like the one you were working on today?
No, but I can paste it just in like a Slack announcement or something like that. Yeah, I can certainly share this.
Okay, thank you.
I'll also have to share the images, otherwise nothing will load, and then that would just be sort of chaos. Blake, do you have a question?
Yeah, so I was wondering, like I've worked a little bit with events and event handlers before, like in Java when I was doing AP Computer Science, but I never really understood like how that's handled under the hood, and I'm curious if you could try to help me understand that.
So generally, I don't know exactly how Java has them implemented, but most languages are approximately the same. The idea of events, event handlers, callback functions, or whatever else, it's basically something called function pointers. And so the idea of, I know, I said the dreaded P word, but function pointer is essentially, well, it relies on the concept that a function is really just a block of memory. And so we don't think of it necessarily like that at first, but functions reside in memory more or less like anything else. And so if we know that, then we can create a pointer to that memory. And so trying to invoke a function doesn't necessarily require that we're in the same file as that function. And that's where it starts to get a little bit wonky for, especially for students. I know the first time I ever heard about function pointers, I was like, what is this nonsense? Slash, what is this magic? So let's say I write a function here in main and, or in my main.cpp, and I just call this function. If I wanted to actually invoke this, then, oops, sorry, actually clicked and dragged there. If I wanted to invoke this, I'd have to be inside of main.cpp. And that's just the way it is. I couldn't go to another file, say some class that I wrote, and then call function, because that doesn't exist anywhere. However, if we could get a pointer to this function, then I could just send a pointer to some other code. And now that code knows about this function, even though they're in totally separate files. For the same reason that if I make a class and I define that class in some other file, and then in main, I send a pointer to that object, well, that object that gets created somewhere in memory knows about this other thing somewhere in memory. Bringing that all back around, events are more or less function pointers. And once we start to store those things, we can tell some system like, hey, do you remember that function that you were instructed to keep track of sometime in the past? Yeah, I do remember that function. What of it? Could you please call that function right now? Okay, sure, sounds good. And we kind of wire up these events beforehand. Then when our program runs, we can make use of that wiring, so to speak. If that helps make some sense of it.
I think so, yeah. So the event handler, excuse me, the event handler would be like continuously checking to see if any events are triggered, and then the event would have a pointer to a function.
Essentially, yes. And so the event itself might be some kind of built-in function or some sort of a process that is awaiting notification from something else. Operating systems tend to have a lot of common events. So like when a program starts, that might be sort of a formal event that the operating system is aware of. Or in the case of a program like Windows, if a window maximizes or minimizes, or if I drag it to the side of the screen and then it does the autofill or snapping or whatever, those are all different kinds of events that the operating system might send out, and I could potentially write some code to receive that and then do something in response to it. Other common events are just like a mouse press or a window coming into focus, or being minimized or losing focus, and all those other sorts of things. So we can also start to build our own event systems, which gets a little bit more complicated, but the idea is still the same. We're defining some kind of criteria, and like you said, have something that's sort of waiting and constantly checking, like, is this criteria met yet? Is this criteria met yet? In the same way that if somebody tells you, hey, could you keep an eye out for this person coming down the hallway and just let me know when they're coming, or whatever else, keeping a lookout or something. You're constantly scanning, like, is the person here yet? Is the person here yet? Even though you might not ask yourself that or repeat that over and over again, that's kind of what you're doing. So we just put that into code and simulate the same thing.
Gotcha. And that would be like a different thread that is handling the listening for events, I'm guessing.
It could be a different thread. In modern applications, it would likely be a separate thread, but it doesn't have to be, because really, multi-threading is really just it's like taking this much code to execute, and we're sort of doing this. So instead of all of our code executing one after another, we're saying, you know what, maybe we can do some of these at the same time. That'll just speed up performance, which it might be helpful to do that on a thread. Otherwise, we could just say at the very top, let's do a check. Have we found the things we need yet? No? Okay, cool. Let's do all the other stuff. Once all that's done, let's do a check again. Have we encountered any events? No? Okay, let's go do the other stuff. I mean, that's kind of what sfml is doing with this sort of loop right here. I don't know if they have a threading system set up for all of this, but threading can get very complicated. And then there's, you know, OS threads and processor threads. There's tons of stuff that we could worry about there, but
Yeah.
that sort of depends on the unique circumstances of some environment.
Cool and terrifying. Thank you.
You're welcome. Tristan, do you have a question?
Heyo, yeah. It's about the study guide for the sorting quiz.
Okay.
Just like, so for binary and linear search, I know binary is, you know, faster. And then it says, is it always faster? And that would be no, right? Because like when I was testing linear search, because doing the code tutorial, I did a search for like, I think the first element in the array, and clearly like linear search was quicker. So it's like not always quicker, but majority of the time it
Depends.
is.
I mean, that's the
But-
thing with when we're talking about performance and sorting and just kind of performance in general, there are, for almost everything, there's a big asterisk next to it. It depends. And that's true of almost everything. It's very rare that we can make some universally true statement about the field of computing because it's so complicated.
Yeah.
And there are so many factors in any one scenario. You know, so while it's often very helpful, especially for early students, to say, this is the way it always is. Okay, got it. I'm going to memorize, this is the way it always is, because that just helps us learn things. But then 2 weeks later, hey, you remember that thing where it's always this way? Okay, let's talk about exceptions and let's talk about special cases. Like, wait a minute, but I just memorized it's always this way. Yeah, that was just to make it easier. You know, we do that from an early level, you know, with school children, grade school or whatever else. And for complex topics as adults, we sometimes, let's just focus on this one little case. This is the way it is. And then we'll slowly expand and slowly expand. And that's true of sorting or anything else.
Sweet. Yeah. Thank you.
You're welcome. All right. Any other questions? If there were any questions in the chat, it's entirely possible that I've missed them because I just can't keep track of all that. So my apologies. But let's see here. Ryan, that's a big question. How do random number generators generate random numbers? Are they actually random? The first question is very difficult to answer. In short, how do they do it with an algorithm? Exactly what the form of that algorithm is, well, that depends. There are many random number generators in many languages and even multiple within a language. And also that aspect of computer science, random numbers, is not my area of expertise. So I can't answer that very completely, unfortunately. The second question, however, are they actually random? No, they're not. More accurately, random numbers are called pseudo random number generators. And so, although it gets to be clunky and a bit of a pain in the butt to constantly call them pseudo random, just call them random. And it's understood that they're pseudo. The reason we call them pseudo random numbers is because when we write a program, a human being wrote that program, right? A person wrote the instructions for whatever that code is doing, which means that code has to do something predictable and reliable because a human being coded it that way, right? And even if we get into, you know, algorithms generated by algorithms, that's a whole other thing. It was still a set of instructions that were written to do a specific task. If we know what those instructions are, then we can know what the random numbers happen to be. So that's why we call them pseudo, because they're just running off of an algorithm. That said, there are many aspects of pseudo random number generation that are designed to make the algorithm as unpredictable as possible, which is very good, because if we're talking about things like security or encryption or whatever else, we don't want to have something be predictable, because if somebody can predict the algorithm and if they know exactly how the number is generated, well, then they can predict what the sequence of numbers will be, and then they can start to break down any kind of security or encryption that relies on randomization, which is a very, very bad thing. So a lot of random number generation algorithms will use all kinds of input variables, including things like the temperature of different kinds of components in your computer, because that's extremely difficult to predict. That can fluctuate on a second to second basis and so on. They might use things like your system time, different kinds of hardware IDs, and all sorts of other stuff to make the initial sort of random seed process as difficult to predict as possible. But again, exactly what that algorithm is, I couldn't tell you. And that is, yes, that's why I passed the time to this sran function to seed this. So what this is really saying is, based on the current system time, start the random number generator. Maybe word that a little bit differently. Start the random number generator based on the current system time would be a more perhaps apt description, right? And so every time my program runs, my system time will be a little bit different. If I run the program 10 times in rapid succession, it still might be, milliseconds or fractions of a second off, which will be a different sequence of random numbers that get generated. And that's why if I don't do this, then whatever seed number it happens to use will be the same every single time. Yeah, so seeding random number generators, that's an easy part. That's sort of how to use the number generator. How exactly does the generator work, or how is it written? That I couldn't tell you. There are many aspects of programming that are like that. We can learn how to use them, but unless we really want to write one of those kinds of things ourselves, we might go many years or decades without learning exactly how it works. And every language is potentially different. Can I use my own sleep schedule as a seed? Sure, if you wanted to. I mean, any number could be used as a seed number. I think sran can just take any number. So let's see. Yeah, it just takes an unsigned int. So I could say, let's use a seed of 7. So that's going to be a sequence of random numbers. And if I run this, it'll be, according to whatever pattern based on the starting value of 7. Now, I don't know what that sequence is, and we get, some sort of result here. And, if we sort of take a snapshot of this, if we were to run the program again, it should give us identical results. And so we look at these two, let's see, we can do something like this. We get exactly the same results. We have these 5, it's kind of like a weird little dipper or something up there, same little dipper right here. So random results, and yet we're getting exactly the same random results because of the starting seed. If that seed is different, then we'll get different numbers as a result. And that's why in games that do a lot of random generation, something like Minecraft or Civilization or something like that, that generates random maps or environments, the map that gets generated, oftentimes the developers will expose that seed number, and it might be some, humongous unsigned int number, something sort of like this or whatever. And so if you give somebody this exact same seed number and say, hey, I want you to start up a game of Minecraft and use this as the world seed, and they type that in, they'll get exactly the same world that you get, which is cool, because then you can kind of share in the reproducible randomness, right? And that's why they're called pseudo random number generators, because they can be reliably reproduced given certain kinds of parameters. Because maybe, you know, you start up a game of Minecraft and it's like, oh, look at this really cool mountain that got generated, or this really neat cave network right by my starting location. And then you could kind of, you know, share in that experience with someone else. Or if you just wanted to replay, you know, a really fun map or board or game of whatever you're playing, repeat the seed and get the same kind of experience, right? So I haven't really done, you know, a lot of sort of work in investigation into like exactly how the random number generation works. Frankly, that's just not something I'm especially interested in. But from a higher level perspective, you know, how to put that to work, how to utilize random numbers and do something cool with them, I'm far more interested in that. And you know, that kind of goes. There's different levels of programmer, right? Or sort of categories, I guess. There's like low-level programmers who want to build a random number generator and generate the most effective random numbers that anyone has ever seen. And then there are higher-level programmers that want to take that and write other kinds of code and build a program that uses those random numbers. Both are perfectly valid career choices. Both are equally viable. Both are extremely important. And neither is superior to the other. Right. And I will always tell students that because somebody listening to this might be of the mindset where, oh, that's the low level stuff. That seems kind of cool. I want to learn a little bit more about that. Me personally, I'm not interested in the low level stuff as much. I would much rather do the higher level stuff. But I would never tell a student like, oh, you want to write your own random number generator. Oh, that's just, don't waste your time on that. If you want to do that, then you should learn everything you can about that and try and, you know, build a better mousetrap essentially and improve that kind of technology. If you don't, that's okay as well. And if you just want to write higher level stuff. So I'll always tell students like, it's okay, whichever one you choose, mostly because I have, you know, very large classes and I don't know what every one of my hundreds of students wants to do. So I try and be very careful and never say one thing or another based on my own personal preference is superior or inferior, because that's just kind of silly. That's just sort of, you know, an elitist kind of attitude that I don't think anybody should have. The world is an enormous place and there is room for everyone. Should turn this back to time. So anyway, hopefully that answered your question in a very long-winded, roundabout sort of way, as you know, unfortunately I am prone to do from time to time. But hopefully that answered your question, Ryan. You're welcome. Does anybody else have any other questions for any who may still be here? You're welcome, Catherine. Richard, what's the difference between a sprite and a textured rectangle shape? In terms of just visual appearance, really nothing. I think using the sprite might be a little bit easier just because it kind of natively supports the use of textures. Well, I think the rectangle shape does as well. I think actually maybe more the rectangle shape by default, you can just make it and draw it and it will appear. A sprite, on the other hand, as we saw earlier, if you just make it and draw it, nothing appears because it has no default appearance. So I think if you apply a texture to a rectangle shape, it will appear exactly the same. And I don't think I've ever actually tried that. Yeah, I just never really had a need to use the rectangle shape for that, but from a visual perspective, really no difference. And I think the rectangle shape and the sprite, they both derive from, I think they both have the same base class as drawable, I think, is the base class in SFML. And I think it's the drawable class that has things like getting the global bounds and other sort of stuff that they both share. Yeah, it is drawable. So yeah, not a whole lot of difference really. Now, there could also be some additional functions maybe that the rectangle has that the sprite doesn't, or vice versa. I'm not sure. I've not done like a side-by-side comparison of the two, but I'm sure there's something in there that's a little bit different. Whether it's sprite has something that rectangle doesn't, or vice versa. But off the top of my head, not a tremendous amount really. And if you're just going for, drawing something on the screen, drawing a particular image, you could do it either way. Any other questions? Because that was the random one. Time. Oh, and I see that. Yeah, earlier. Sorry, I missed that. After answering Ryan's question in a very long-winded, roundabout way. I think that might be it in the chat there. Yeah. Any other questions, comments, concerns? All right. Well, then have a good night, everybody. I will see you all on Monday.